Okay, so coming back to number 3, hopefully you got it right. If not, we'll check out what happened. We see they're already lined up. When we go to add, we've got an understood 1x here plus 3x gives us 4x. A negative 1y plus 1y will cancel each other out, so it's like 0. 10 plus 18 gives us 28. So if 4x equals 28, when I divide by 4, x equals 7. Plug that back into either one of the equations. I'll use the top one. And if it was x minus y equals 10, we found out that x was 7. So I got 7 minus y equals 10. So when I minus 7 from both sides, I get negative y equals 3. And when I divide both sides by that negative 1 out front, a positive 3 divided by negative 1 tells me y is negative 3. And so my ordered pair, x going first, should be 7, negative 3. That was the answer to number 3. Okay, so moving on to a next possibility. So sometimes they're not lined up and ready to go. So I do have x over x, y over y, equal over equal, and constant over constant. But if I try to add it the way it is right now, 4 plus negative 2 is still going to leave me 2x, and 2 plus 2 is going to leave me 4y. Well, I have both variables here. I only need to have one. I need either the y's to cancel or the x's to cancel. Well, I'm going to look for what's the easiest. Technically, to make the x's cancel, this would just need to be a positive 4, and this would need to be a negative 4. So I could truly multiply this second equation by a positive 2 and distribute to everything, and it will make the x's cancel. But there's an even easier way. If I look closely at the y's, they already both have a coefficient of 2. The only issue is that they're both positive. I need one of these 2's to be negative. I can choose to change the top equation or the bottom equation. In order to make this positive 2 into a negative 2, I need to multiply by a negative 1. Well, I can't just do that to y. If I choose to do that, I need to do that to the entire equation to maintain equivalence. I have to make sure I distribute this negative 1 to all 3 terms in the top equation. So it's going to change this to a totally new equivalent equation. I will now have a negative 4x, a negative 2y, and it's going to equal a negative 6. So I'm going to use my new equation for the top one, and I'm going to keep my bottom one the same. And we're still adding together the 2 equations. Negative 4x plus negative 2x is going to give us negative 6x. Negative 2y plus 2y now cancel, that's why we did what we did. Negative 6 plus 8 leaves me with a positive 12. And so if negative 6 equals 12, then when I divide both sides by negative 6, x equals negative 2. Plug that value for x back into either one of the equations. I'll probably use the bottom one just because it looks like mostly smaller numbers. It doesn't really matter. I could use the top one. All that matters is that negative 2 goes where x is. So if I use the bottom one, got negative 2 times x plus 2y equals 18. And I know that x is negative 2. So when I multiply, that's positive 4 plus 2y equals 18, minus 4 from both sides. 2y equals 14, and so when I divide by 2, y equals 14 divided by 2 is 7. So our answer has to be an ordered pair, x first, negative 2, 7. That would be our answer. That's the point where they intersect. Let's try one more like that. So this time it doesn't look the same as it's been looking, but what matters is that they're lined up. Y is over y, equals over equal, x is over x, and the constants over the constants. So let's see if we try to add, if anything will cancel right now. Well, 1y plus 1y gives me 2y, equals 3x plus 1x gives me 4x. I still have both of them in the equation. That's an issue. I either got to make the y's cancel or the x's cancel. Again, there's actually 2 different options. If I wanted to make the y's cancel, they both already have 1's here. The problem is that they're both positive. I would need to make one of them negative. If I wanted to make the x's cancel, since this one has a positive 3, I would have to make this one have a negative 3. So those are my two options. I can either make the y's cancel by making one of them negative, or I can make the x's cancel by changing this to have a -3 coefficient, so they'll cancel. The easier route is just going to be to make the y's cancel out. So if this one needs to be changed negative, I need to multiply by -1. Or if this one is the one I choose to change, I'll multiply by -1. Doesn't matter. This time I'll choose the bottom one, just because last time I did the top one. When I multiply by negative, though, I have to distribute -1 to everything inside of the equation. It has to distribute. I didn't change the top one, so I'm just going to rewrite it. The bottom one becomes -y equals -x, and a -1 times a -2 gives me +2. I'm technically adding the two equations. 1y plus -1y just leaves me with 0, because there's no y's left. 3x plus -1x leaves me with 2x. 4 plus 2 leaves me with a +6. Now it's just an x, so I can solve for it. -6 on both sides. If -6 equals 2x, then x is equal to -3. Take that value, because now I need to find out what y is equal to. Plug it into either one of these equations. I'll use the bottom one. Y equals x minus 2. We just found out x is -3. -3 minus 2 is -5. So the solution is the point -3, -5. Alright, we're to another checkpoint. Go ahead and try number 6 with your partner. You may have to change at least one of the equations. It doesn't matter which one, as long as the numbers out front are opposites and they're the same number. That's what has to happen for it to cancel out.